Hey everybody, Mr. Judson here. So today we want to look at this thing called the rational zero test. All right. What it is, it's a way to help us find numbers that will work with synthetic division. So the test says this: if you have a polynomial, ax to the n plus bx to the n minus 1, it means one less than this exponent, and so on, all the way down to our x term and then some number by itself. All right. So this n minus 1 and n minus 2, it just means our exponents are decreasing. Then the polynomial has zeros at factors of z, this number, divided by the factors of a, this number right here. Okay. Now remember, the word rational means numbers that can be written as a fraction. Okay, numbers that can be written as a fraction. And so that's why we see a fraction here. If there's a number that's going to work with synthetic division, it's got to be one of these factors of this number at the end divided by factors of this number here. And since 1 is a factor of everything, that means the factors of this number are included in that group. Okay, it's like a number over 1. Let's do an example, because I think that would help. So let's say I've got p of x, just p for polynomial, equals 4x cubed minus 2x squared plus 17x minus 6. Okay, and let's say I think there's some zeros there, and I want to try and use synthetic division to find them, but I'm not getting any hints. Okay, remember our past assignments, we got some hints. We got some help on how to get started. Today we get no help. Okay? But we're going to use this rule that says take all the factors of 6 and divide it by the factors of 4. So let's see, the numbers that divide into 4 evenly would be 1, 2, and 4. The numbers that divide into 6 evenly would be 1, 2, 3, and 6. And so what I'm going to say is that my possible rational roots, okay, it doesn't mean that all of these are, it means it's possible that some of these are. Possible zeros. Well, let's see. If all of these numbers are divided by 1, we just get that same list that we have there. So we're going to have 1, 2, 3, and 6. And then if I take all those and divide them by 2, I would get 1/2. 2 over 2 is 1, and it's already listed. And then I'd have 3 over 2, so 3/2. And then 6 over 2, that's 3, and it's already listed. And then I got to divide them all by 4, so I'd get 1/4, 2/4, which is the same as 1/2, 3/4, and then 6/4, which is the same as 3/2. So there's my list of possible numbers that could work on this with synthetic division. Now, because I have a negative here at the end, and really it doesn't even matter if it's positive, I could do a negative number times a negative number to get something positive, or I could do a positive times a negative. It means it's possible that maybe one of these is negative and not positive. And so what I usually do is I just say plus or minus, just so I don't have to write the whole list over again. So if there's a number that's going to work with synthetic division, it has to come out of this list. And so now at this point, if I wanted to find the zeros, I would begin trying these numbers. All right? Now, I'm not going to do that because I just made this polynomial up, so I doubt if any of them would work. It was just a random polynomial. Okay? But if synthetic division is going to work, it's going to work with either 1, 2, 3, 6, or one of these fractions. What I always hope is that I find it before I get to the fractions, because I don't want to do synthetic division with fractions if I don't have to. All right, so one thing that's really important about this is if I was going to find the zeros now, I have to be willing to guess and check until I find it. You know, people who are like, well, I don't like to guess. well then you're not going to make it. You know, we have to be willing to guess, and we have to be willing to get it wrong in order to find the answer. That's just a normal part of the procedure, okay? Happens to me all the time. I don't have any tricks where I look at this and know what the answer is. I actually have one trick. I'll share it with you guys when we get there, but yeah, I don't have something special up my sleeve that helps me do this any faster than you guys. All right, so these are the numbers that would work if synthetic division worked. There are no other numbers to even try, all right? Let's try one where we do get some answers. All right, so this question is asking us to find the zeros for this polynomial, okay? P of x for polynomial. So if I was going to do that, the numbers that I want to try are the numbers that divide into 12 evenly. So plus or minus 1, 2 divides into there, 3 does, 4 does, 5 doesn't, 6 does, 8 doesn't, and then 12. Okay, I just list them in order. Okay, divided by all the factors of this first coefficient, which that's the number 1. So divide all these by 1, you just get the same list. Okay, I like it when this happens. There's no fractions to worry about. So now I just need to do synthetic division and pick some numbers and try it. So let me set up my synthetic division. I've got 1, -9, 20, and -12. All right, so I told you I had one trick, and this is the only trick I have. If these numbers all add up to 0, then I automatically know 1 works. Okay? Add them up. You get -8, -8 plus 20, that's a positive 12, minus 12, that's 0. Anytime that happens, you know that 1 works. If they don't add up to 0, well then we can skip the first number. Start with the next one. All right, so I'm going to do synthetic division with a 1. So I bring the first number straight down. I wrote a smaller box here because this looked easy to me. I can do this in my head. 1 times 1 is 1. Add it to this, you get -8. Multiply here, you get -8. Add it to this, you get 12. And then 12 minus 12, that's 0. So this worked. So remember, that means that one of my factors is going to be x minus 1. And so I'm now going to write that down here. X minus 1 times, this was x cubed, so this is now x squared, minus 8x plus 12. Every time I get down to 3 numbers, I'm then going to write that as a quadratic because now I can factor that. Now some people might say, well, couldn't I do synthetic division with these 3 numbers here and try and find another one? Sure, you could. I feel like factoring is easier, but if someone thinks, no, Mr. Judson, synthetic division is easier, go ahead and do it that way. Okay, that works. So I've got x minus 1, 2 numbers you multiply to get 12 and add to get a -8. It's got to be x minus 2 and x minus 6. Okay, -6x minus 2x, that adds up to a -8x. And there's my zeros. Whoops. So I've got zeros at x equals 1, 2, and 6. Okay, and notice those were in my list. Those were some of the numbers that we said would work if something's going to work. Okay. If I would have tried to factor this by grouping, it wouldn't work. Because once I factor an x squared out of here, I'm left with x minus 9. I can't get this to be an x minus 9 by factoring something out. So I need synthetic division. I need this method to help me factor those expressions. Now, if I was going to graph this, and most of the problems today we don't have to graph, but if I was, I would set up a graph, and I would look at this and say, I'm crossing the x-axis at 1, 2, and 6. So cross the x-axis at 1, 2, and 6. And I also know that my y-intercept is always this number out here that's by itself, negative 12. So if I count on the y-axis by 2's, this would be 2, 4, 6, 8, 10, 12 right there. And we can also think about our end behavior. Our highest exponent is a 3, and so if I take a negative number way out here and cube it, I'm going to get a negative result. If I take a positive number and cube it, I get a positive result. So this graph needs to be increasing to the right, decreasing to the left. I think it's actually going to go down through that point right there. And you can just kind of look at this and tell what's happening. Okay, now again, is it perfect? I don't think so, because I didn't check to see, what's this low point here? This is a time where I would maybe want to find some additional points. Let me have you guys try one. All right, so we're trying to find the zeros for this polynomial. P of x equals x to the 4th plus x cubed minus 12x squared plus 4x plus 16. Now, remember, the highest exponent is the degree of this polynomial. So this is a 4th degree polynomial. It also means I could cross the x-axis up to 4 different times. Okay? Not always 4, but no more than 4. Okay? Potentially, I could cross up to 4 times. So, if I do synthetic division, I want to think, what are the factors of 16? That would be 1, 2, 4, 8, and 16. Okay? So not too bad. There's no factors here other than 1, so I don't have to worry about fractions. And so let me write down my coefficients. I've got 1, 1, negative 12, 4, and 16. Do these numbers all add up to 0? No. So that means 1 doesn't work, right? So I can skip 1, I can go straight to 2. Let's just see what happens. Bring this down, multiply, you get 2, add it to the next, you get 3. 6 minus 12, that's negative 6. A negative 12 plus 4, that's going to be a negative 8. And then a negative 16 plus 16, that's 0. So I got lucky, I found one. I haven't made a guess yet that hasn't worked, all right? So now I'm going to try and find another one. And so that means I'm going to work with these numbers now. I don't want to keep on going back to the first set of numbers because what I want is for this to get easier as I go. So I'm now going to try another number. Let's just say I try 3. Bring the first number down, multiply, you get 3, add to this, you get 6. Here I get 18 minus 6, that's 12. 3, that's going to be 36. Minus 8, that's 28. That didn't work. Okay? But it's not a waste of time because, remember, 3 comma 28, that's a point on the graph. I'll just write it here, 3 comma 28. If I'm going to graph later, I could use that information. Okay? Now, since this didn't work, I just draw a line through it and then pick another number. That didn't work. Let's try 4. Okay? So I bring the first number down. I multiply, I get 4. Add that to 3, I get 7. Multiply here, I get 28 minus 6, that's 22. Here I get 88 minus 8, that's not going to work either. Cross it off. Let's try another number. So maybe this time, instead of trying 8, maybe I want to go and try a negative number. Let's try negative 1. So if I bring the first number down, then I get negative 1 plus 3, that's going to be 2. And then I get negative 2 minus 6, that's going to be a negative 8. And then I get positive 8, minus 8, that's going to be 0. So I found another one, right? I've got 2 zeros now. Those are my zeros. As factors, this would be x minus 2, this would be x plus 2. Okay? And that's what I would have down here at this point. I would have x minus 2 times x plus 1. This would now be x squared plus 2x minus 8. And so the only question is, could I factor this farther? Remember, I told you guys, every time I get down to 3 numbers, I'm going to write it as a quadratic because I think those are easier to factor. It's easier than continuing to guess and check and make mistakes, you know. So now I look at this and say this is x minus 2 times x plus 1. This will be x times x. 2 numbers you multiply, you get 8, and subtract to get a positive 2. That's got to be a positive 4 and a negative 2. So x squared, that's this term, minus 2x plus 4x, that adds up to these. And then a negative 2 times 4, that's a negative 8. So there it is. So my zeros are at x equals 2 and 2. That means I've got an even multiplicity, right? So on the x-axis at 2, my graph is going to do something like this if I had to draw a picture of it. And negative 1 and negative 4. There's my zeros. Now again, they didn't ask us to graph it. All we had to do was find the zeros. But if I was going to graph it, I know we're crossing the x-axis at 2, negative 1, and negative 4. And I also know that at x equals 2, because that happened twice, our graph is either going to go like this or like this. I'm not sure which one yet. I'd have to go back and look at the original function. So this is my dominant term. It's the largest exponent. And if you put a positive number in there and raise it to the 4th power, you get a positive result back. If I take a negative number way out here and raise it to the 4th power, I also get something positive. So this graph is going up on both ends. Okay? My y-intercept is negative or positive 16. So let's see, if I count by, let's go 5s. There's 5, 10, 15, 16 would be right there. Remember, I've got this additional point, 3 comma 28. So there's 3, 5, 10, 15, 20, 25, maybe somewhere right about there. It bounces at 2, it goes through the x-axis at these 2 points. So I think I know what this graph looks like now. My end behavior says we're going up because if you take a negative number and raise it to the 4th power, you get something positive. Same thing over here. I think the rest of the graph is going to look like this. So if we went and graphed this on our graphing calculator, we should see something pretty close to that. So here's something that's interesting. When you hear a teacher say that, if we were to graph this on our calculator, we should get something pretty close to this. I always wonder how many people would actually graph it to see if that's true. And I think what happens is, for those who do, if you go, I wonder if you do get that, I'm going to check. Those are the kind of people that are always checking details, making sure they really understand it. They tend to do better. So when you guys hear me say something like that, if we were to graph this, it should look like this. I know when I was a student, I would have been grabbing my graphing calculator, if we had them back then. We didn't. But I would be punching that equation in and checking to see, does it look like that? I don't expect it to look exactly like that, but it should be pretty close to it. Okay? All right, let me get you guys one to try completely on your own. I think I was going to stop partway and say, here, you guys finish it, but I forgot to. Anytime I do that, you can always pause the video if you want and try it on your own and then see how you're doing. All right, so one thing I really want to make sure that we all get is factors and zeros and x-intercepts and solutions. These are all done exactly the same way. If I said factor this expression, then I'm going to use synthetic division to find the factors. If I say find the zeros, I'm going to use synthetic division to find the factors, and once I see the factors, I know what the zeros are. If I'm looking for x-intercepts, I'm going to do synthetic division until I find the factors, and then I'll know what the zeros are, and those zeros are my x-intercepts. If I'm trying to solve an equation, if I'm looking for solutions, then I'm going to do synthetic division, get the factors. When it's set equal to 0, I know I just take the opposite. Those are my zeros, my solutions. These are all the same. Okay? Technically, they're not exactly the same, but they're pretty darn close to the same. Okay? You guys go ahead and try this one. I want you to solve this equation, which really means we're looking for zeros. Okay? Where is this whole thing equal to 0? You guys go ahead and try it. All right, so I'm pretty sure there's going to be a fraction somewhere in this one because of that 2. Okay, but let's just think, what numbers would we try? Well, numbers that divide into 25 would be 1, 5, 25. And then I got to divide all those by the factors of 2, which would be 1 and 2. When you divide by 1, you get the same list. Okay, so I'll divide them all by 2. I could get 1/2 or 5/2 or 25 halves. Now, here's the thing. Nobody wants to try synthetic division with fractions if you don't have to. I don't want to do it if I don't have to, right? So what I'm going to do is I'm going to see if 1, 5, or 25, or -1, -5. Actually, I'll probably do the 2 positive ones first. And if I don't find at least 2 of them, then I'll go to a negative number. Okay, but I'm not going to try the more complicated stuff first. I'm hoping I get that at the very end when I factor my quadratic. All right, so I've got 2, -15, 23, +15, and -25. And I'm going to do synthetic division with, looks like these might add up to 0. I'm going to try 1 first. So I'll bring the 2 down. When I multiply, I get 2. Add that to a -15, you get -13. Multiply, you get -13. Add it to this, you get 10. Multiply here, you get 10. Add it to this, you get 25. Multiply here, you get 25 minus 25, that's 0. There's one of my solutions right there. Okay, all we're doing now is solving the equation. Got to find 3 more, right? Because you could have as many as 4 solutions. But now I'm just working with these 4 numbers. I'm no longer working with this one. Okay, cross this off, we'll cross that off. So I still have the same list of numbers because my last number and my first number haven't changed. So I'm still working with this list. 1's not going to work again, right? This does not add up to 0. So let's go to 5. Bring the first number down. Multiply, you get 10. Add it to this, you get -3. All right, so multiply here, you get -15. Add it to this, you get -5. And then here you get -25 plus 25, that's 0. I just found my second solution. And I'm just guessing. I'm getting really lucky here. I'm just guessing, and I'm getting it right. I think that last example I missed a few. But that happens sometimes. You just make a guess and you get lucky. At this point, I no longer want to try synthetic division because I'm down to 3 terms, which means I have a quadratic expression. And so I'm going to write this as 2x squared minus 3x minus 5. And I want to try and factor this. This has to be 2x times x, It's the only option. You know, maybe you put the x first and the 2x second, but still same set of numbers. This can only be 1 times 5. So I got to make sure that can work. So let's see, if I put a 5 here and a 1 there, I get 5x and 2x. I could subtract those to get a negative 3 if that one was negative and that one was positive. Right? 2x squared, and then I get 2x minus 5x, that would be a negative 3x, and multiply those two, you get negative 5. Other factors were x minus 1 and x minus 5. So now my solutions are x equals 1, 5, positive 5 over 2, there's my fraction, and negative 1. There's my 4 solutions. All right, so we've taken this idea of synthetic division and tried to push it a little farther. I will tell you guys, we're supposed to be dealing with imaginary numbers right now, which is like the square root of negative 4. You get the answer 2i. If you've never seen that before, not a big deal. It's very rarely used in math. We don't even see it in calculus. I need to find a way to buy us some time, and so by skipping this, we're going to gain 2 days. It also means that where we would normally get answers here that have imaginary answers, I'm going to try and avoid all of those problems as well. Okay? All right, so our big push for today is to realize that factors and zeros and x-intercepts and solutions for polynomials are all found the same way. They're found with synthetic division. And the new thing that we've learned today is, you know, what numbers do I try when they don't give me any hints? And it's got to be the factors of that last number. Almost always, one of those is going to work. Okay? Almost always. Not always, but almost. In our class, they'll work. All right? All right. Let me get you guys a homework assignment. All right, so here's our work for today. It's assignment number 12. This is our Thursday, Friday assignment, depending on which class you're in. Page 179, we're going to do 11 to 29 odd. All right, that's it. That's all I have for today. You guys take care, stay safe. Don't forget, you need to email me and let me know what time you're taking the test, either normal class time or at 6 o'clock or 6:30 in the evening. Okay, we all should have gotten an email on that. All right, you guys take care.